Welcome to this long, gentle journey through the cosmos, where together we will explore one of the most extraordinary worlds in our solar system, the planet Jupiter. This lecture is designed not only to inform, but also to calm and relax you, letting your mind drift as you listen to the slow unfolding of science and wonder. Over the next 10 hours, we will travel through Jupiter's mysteries, returning again and again to the central question: how massive is Jupiter? To begin, let us place Jupiter in context. The solar system, our cosmic neighborhood, is a family of 8 major planets orbiting the Sun, along with countless moons, asteroids, and comets. Among all these worlds, Jupiter reigns supreme as the largest, the most massive, and in many ways the most influential. It sits fifth from the Sun, after Mercury, Venus, Earth, and Mars. But unlike the small, rocky inner planets, Jupiter is a gas giant, an enormous sphere of mostly hydrogen and helium, more like a failed star than a solid planet. Now, consider its sheer presence. Jupiter's diameter is about 142,000 kilometers. That means you could line up 11 Earths side by side across its width. Imagine our home planet Earth, repeated again and again, one next to another until 11 are joined in a line. That entire chain would only just stretch across Jupiter's girth, but diameter alone does not tell the whole story. It is Jupiter's mass that truly astonishes astronomers. Mass is not just size, it is the amount of matter, the total substance contained within. Jupiter's mass is 318 times greater than Earth's. Let us pause on that number because it is immense. If you could somehow combine 318 Earths together, merging them into a single colossal sphere, the result would weigh about the same as Jupiter. Picture our world, with its oceans and continents and atmosphere replicated hundreds of times, then pressed together into one gigantic planet. That is Jupiter. Even more striking is Jupiter's dominance within the solar system. If you were to gather up all the planets, Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune, every one of them combined would still weigh less than half of what Jupiter alone contains. Jupiter is not just the biggest planet. It is the anchor, the gravitational giant that helps hold the solar system together. To understand this mass in familiar terms, imagine trying to weigh Jupiter against something tangible. If Earth were a coin in your hand, Jupiter would be a heavy stone boulder towering over you. If Earth were a family car, Jupiter would be an aircraft carrier. Its weight, its gravity, its presence. It is beyond ordinary comprehension. And yet, despite all this weight, Jupiter is not a solid planet. Unlike Earth, with its rocky crust and mantle and core, Jupiter is composed mostly of gas. That gas is squeezed and compressed under enormous pressure, creating a planet that is both light in structure and heavy in substance. Jupiter's density is less than that of Earth. If you could place Jupiter in a vast cosmic ocean, it would float a little more easily than Earth would, because it is made of lighter elements. But the sheer amount of those lighter elements, the quantity of hydrogen and helium, makes its overall weight titanic. Jupiter's mass also determines its role in the solar system. Its gravity is so strong that it shapes the paths of comets and asteroids, sometimes pulling them in, sometimes flinging them away like a slingshot. It has been called the solar system's guardian, sweeping space clean of dangerous objects that might otherwise collide with Earth. Without Jupiter's massive presence, our world might face far more frequent catastrophic impacts. But let us return again to the question: how massive is Jupiter? Consider that if Jupiter were only about 80 times more massive, it would not be a planet at all but a star. That is how close Jupiter is to stardom. It is sometimes described as a failed star, because its bulk is just shy of the threshold needed for nuclear fusion to ignite at its core. Instead, it glows faintly in infrared light, radiating more energy than it receives from the sun, a reminder of its internal heat and power. Take a moment to let that sink in. Jupiter is not simply a large planet. It is a planet on the very edge of being something more. If it had been only slightly larger at birth, the solar system would be a binary star system, with Jupiter shining alongside the sun. We on Earth would live under 2 suns, much like the fictional worlds of science fiction. That is the scale of Jupiter's almost star mass. Let us explore another perspective. Imagine stacking planets by size. You begin with tiny Mercury, then Venus, then Earth, then Mars. Already Earth feels large compared to its neighbors, yet as soon as you place Jupiter in the lineup, it dwarfs them all. It dwarfs Saturn as well, though Saturn is close in size, but much lighter in mass. Uranus and Neptune, impressive as they are, shrink to mere marbles when set beside Jupiter's bulk. In terms of volume, more than 1,300 Earths could fit inside Jupiter. Think about that number, 1,300 Earths. Imagine Earth duplicated again and again, packed tightly into a hollow sphere the size of Jupiter. Yet, because Jupiter is made of lighter gases, those 1,300 Earths combined would still not match Jupiter's total weight. That is how heavy Jupiter truly is. Now, let us reflect on the experience of gravity. If you were somehow able to stand on Jupiter, though you cannot because it has no solid surface, you would feel about 2.5 times the weight you feel on Earth. A person who weighs 70 kilograms on Earth would weigh around 175 kilograms on Jupiter. But remember, there is no ground beneath your feet there, only endless clouds and crushing pressure. You would sink deeper and deeper, pressed by gravity, until you were lost in its storms. And storms are another reflection of Jupiter's mass. The Great Red Spot, a storm larger than Earth, has been raging for centuries. It endures because of the planet's immense gravity and energy, driving winds and patterns that do not fade quickly. Jupiter's size fuels these colossal atmospheric phenomena. As we continue in this lecture, we will return to these ideas from many angles, examining how Jupiter's enormous mass influences its moons, its rings, its magnetic field, and its role in shaping the solar system's destiny. But for now, in this first hour, it is enough to simply marvel at its enormity. Close your eyes if you wish and imagine Jupiter hanging in the blackness of space, a vast sphere of swirling clouds, striped in browns and whites with storms the size of worlds. It spins rapidly, completing a rotation in just under 10 hours, so fast that its equator bulges from the centrifugal force. And beneath those clouds, beneath that speed, lies mass unlike anything else among the planets. When you next look at the night sky, perhaps you will see Jupiter, shining like a brilliant star, one of the brightest points of light in the heavens. Remember then what lies behind that tiny point of light, a world 318 times the mass of Earth, containing most of the matter of the planets combined. A world almost large enough to have been a star, a world whose weight shapes the solar system itself, and this is only the beginning of our journey. We will peel back the layers of Jupiter, exploring its formation, its atmosphere, its core, its moons, and its magnetic field. But always we will return to the same question: how massive is Jupiter? The answer, as you can see, is not only a number, it is a presence, a force, a cosmic truth. As we continue our calm exploration of Jupiter, let us turn now to the story of its beginnings. To understand Jupiter's immense mass, we must ask how it came to be. How did a planet of such colossal size form? Why did Jupiter, among all the worlds in our solar system, grow so much larger than the rest? The story begins more than 4.5 billion years ago, when our solar system itself was young. In that distant past, there was no sun as we know it today, no planets, no moons. Instead, there was a swirling cloud of gas and dust, called the solar nebula. It was vast, stretching across space, filled with tiny grains of matter and light gases like hydrogen and helium. Slowly, under the pull of gravity, this nebula began to collapse, spinning and flattening into a great rotating disk. At its center, the sun was born, igniting into a shining star. But far from that newborn sun, in the outer regions of the disk, the conditions were different. Here, temperatures were cooler and lighter elements could remain stable. It was in this region that Jupiter's story began. Tiny particles, dust grains, frozen ices, and bits of rock started to collide and stick together. At first they were small, no bigger than sand or pebbles. Over countless millions of years, they grew into larger clumps, then into planetesimals, bodies tens and hundreds of kilometers across. The more these bodies grew, the stronger their gravity became. They pulled in more and more material from the surrounding nebula, sweeping their paths clear. This process of accumulation is known as accretion. Among the many forming objects, one in particular began to outgrow the rest. It became the seed of Jupiter. Jupiter's growth followed two stages. First, it built a solid core of rock and ice, estimated to be around 10 times the mass of Earth. Imagine that, 10 Earths worth of material compacted into a single body. This heavy core gave Jupiter a strong gravitational foundation. Once this core was established, the second stage of growth began, and it was explosive. With its strong gravity, the core began to pull in vast amounts of hydrogen and helium, the two lightest, most abundant elements in the universe. These gases were plentiful in the early solar system, especially in the cooler outer regions where Jupiter resided. And because gas is much easier to gather than rock, Jupiter grew quickly, ballooning in size. This is the key to Jupiter's mass. While Earth and the other rocky planets were limited to heavier elements near the Sun, Jupiter had access to the vast reservoirs of hydrogen and helium further out. Its gravity gave it the strength to seize and hold these gases before the newborn Sun's solar winds could blow them away. In this way, Jupiter became a gas giant. Not just large, but enormous. Its core may have been only a fraction of its total size, but the layers of gas surrounding it piled up until Jupiter became the massive planet we see today. Picture the process like a snowball rolling down a hill. At first, it is small, collecting only a little snow. But as it grows larger, it collects faster and faster until it becomes huge and unstoppable. That was Jupiter. Its growth outpaced all others, making it the first planet to truly take shape in the solar system. In fact, scientists believe Jupiter may be the oldest planet, forming before Saturn, Uranus, Neptune, and long before Earth was fully built. It was there early, a giant among small, unfinished worlds. And because it was so massive, it influenced everything else that came after. Its gravity shaped the orbits of nearby planetesimals, sometimes allowing them to merge into other worlds, sometimes scattering them into the outer reaches of space, and sometimes pulling them into itself. Some theories suggest Jupiter may even have limited the growth of Mars. By stirring up the disk with its enormous gravity, it prevented material from gathering in the region where Mars formed, leaving Mars as a smaller world than it might have been. Jupiter's formation was not just its own story, it altered the story of the entire solar system. And yet, it is important to remember that Jupiter stopped just short of becoming something even greater. Had it gathered about 80 times more mass, nuclear fusion would have ignited in its core, and it would have become a star. The solar system, instead of a single sun system, would have been a binary system, with Jupiter shining alongside the sun. Our skies would have been lit by two stars, one golden and one faintly red. But Jupiter did not cross that line. It became a planet, albeit one of extraordinary mass. Let us pause to imagine this ancient time. The solar nebula swirling with gas and dust, the young sun blazing at the center, and in the outer reaches, a giant forming slowly, silently, but with unstoppable force. Piece by piece, particle by particle, gas by gas, Jupiter was born. Its birth explains its weight, not just its size, but its ability to dominate. Its mass is not random. It is the natural result of forming early, forming in the right place, and forming with the right conditions. It is the giant that grew, while others remained small. Let us reflect on this. Jupiter's mass is a story of beginnings. It is the story of how one planet captured the lion's share of the solar system's gas, how it grew until it became the king of planets, and how its very existence shaped the rest of the planetary family. Soon, we will compare Jupiter directly with Earth and the other planets, so that we may see its mass not in isolation, but in relation to the worlds we know best. For now, rest in the thought of Jupiter's birth, the slow, steady gathering of matter, until one world became immense beyond imagination. To truly appreciate Jupiter's vastness, it helps to set it alongside the other planets of our solar system. Comparisons reveal not only numbers but perspectives, helping us see the true scale of this giant world. Let us begin with Earth, our home. Earth, with its oceans and continents, its mountains and valleys, feels immense because it is everything we know. Yet when measured against Jupiter, it becomes small, almost fragile. Jupiter's diameter is more than 11 times that of Earth. Its surface area is over 120 times greater, and in sheer volume, more than 1,300 Earths could fit inside. Imagine creating Earth over and over again, hundreds upon hundreds of times, and placing them gently within a hollow Jupiter. Only then would the space be filled. Volume, however, is not the same as mass. Earth is denser, with a composition of rock, iron, and heavy elements, while Jupiter is primarily hydrogen and helium. Yet sheer bulk overcomes density. Jupiter outweighs Earth 318 times. Picture 318 Earths gathered together, pressed into one enormous whole. Only then would you match Jupiter's gravity. Now picture Mars, often described as Earth's smaller cousin. Mars is about 1/10 of Earth's mass, and against Jupiter it almost vanishes. To equal Jupiter, you would need more than 3,000 Mars-sized planets. Imagine thousands of red worlds scattered across the night sky, and still together they would only just balance Jupiter's colossal weight. What of Mercury and Venus? Mercury, tiny and scorched by the sun, is barely larger than our moon. Nearly 6,000 Mercuries would be needed to match Jupiter. Venus, though nearly Earth's twin in size, still falls short. You would need more than 240 Venuses to rival Jupiter's heaviness. And then there is Saturn. At first glance, Saturn seems a rival, with a diameter close to Jupiter's, about 120,000 kilometers compared to Jupiter's 142,000. But Saturn's beauty hides its lightness. Its mass is only about 1/3 that of Jupiter's. Though similar in size, Jupiter outweighs Saturn more than 2 to 1. Saturn is so low in density that it would float if placed in a vast cosmic ocean. Jupiter, though also gaseous, is more compact, and it is this compactness that gives it dominance. Uranus and Neptune, the distant ice giants, are each larger than Earth but still small beside Jupiter. Uranus is about 14 Earth masses, Neptune about 17. Impressive on their own, but when compared to Jupiter's 318 Earth masses, they fade into insignificance. Now imagine a cosmic scale, a great balance. Place every planet, Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, on one side. Watch as the pan dips under their combined weight. Then place Jupiter alone on the other side. Instantly, Jupiter tips the balance, its mass greater than all the others combined. It holds more than twice the weight of every other planet put together. This comparison shows why Jupiter is not just another planet. It is the anchor of the solar system, the giant around which the others seem to dance. Earth may be our cradle, Saturn may dazzle with rings, Neptune may shine in blue, but Jupiter is the measure of planetary greatness. In its company, all other worlds shrink. To see Jupiter is to see scale itself, a giant that outweighs the rest of the family, a reminder of just how vast a single planet can be. Jupiter's gravity is one of its most remarkable features, a force that extends far beyond what we can see. Its mass is not just a number, it is a presence, a shaping influence on the very fabric of the solar system. Imagine standing near Jupiter, though in reality there is no solid surface. You would feel the pull of its immense mass drawing everything toward its center, a gravitational embrace that affects moons, comets, and even distant asteroids. The strength of Jupiter's gravity is about 2.5 times that of Earth. If you could stand on a solid surface, a person weighing 70 kilograms would suddenly feel 175 kilograms. But Jupiter does not have a conventional surface. Its outer layers are thick clouds, swirling in bands of brown, white, and red, spinning rapidly and generating storms that last for centuries. Gravity pulls at everything beneath those clouds, creating pressure that increases with depth until hydrogen is compressed into a metallic form, generating heat and a magnetic field of astonishing power. Jupiter's influence extends far beyond its visible clouds. It governs the orbits of its many moons, from the volcanic Io to the icy Europa and the enormous Ganymede. Its gravitational pull sculpts their paths, stabilizes them, and at times stretches them, causing tidal heating that fuels volcanic activity and may keep subsurface oceans liquid. Without Jupiter's mass, the solar system would be a less orderly place. Asteroids and comets would follow different paths, and Earth itself might face a greater threat from impacts. Even more distant bodies feel Jupiter's reach. The asteroid belt between Mars and Jupiter owes its current form to the giant's gravity, which prevented the material there from coalescing into a planet. Jupiter's presence protects the inner planets while shaping the outer system. Comets are deflected or captured, sometimes hurled into the Sun, sometimes into distant orbits. Jupiter is both guardian and sculptor, its mass a silent force orchestrating the motion of countless objects across space. The Great Red Spot, the enormous storm visible from Earth, is also a product of Jupiter's mass and rotation. Its sheer weight drives winds that circle the planet at hundreds of kilometers per hour. This storm has persisted for centuries, a testament to the power of a world so massive that it sustains such activity on a scale unimaginable on Earth. As we imagine Jupiter spinning in space, its massive presence affects everything around it. It bends trajectories, holds moons in orbit, channels comets, and dominates the outer solar system. Its gravity is not just a number. It is an active shaping force that defines the structure of the planets and the paths of countless smaller bodies. Consider this. If Jupiter were slightly more massive, its influence would be even greater, potentially altering the course of planetary formation elsewhere. If it were slightly less massive, some moons might drift away, and Earth might face more collisions from asteroids. The precise mass of Jupiter is perfect for the balance we see today, a massive anchor without becoming a second star. Its gravitational reach is also what allows Jupiter to maintain its many rings and complex magnetosphere. Charged particles trapped by its magnetic field follow invisible lines shaped by its gravity and rotation. This magnetosphere is the largest structure in the solar system outside the Sun itself, an invisible cocoon extending millions of kilometers. It shields moons, traps particles, and generates intense radiation that we can measure even across vast distances. By contemplating Jupiter's gravity, we see that mass is not just weight, it is influence. Jupiter's 318 Earth masses do more than sit quietly in space. They actively shape, protect, and guide. Its presence reminds us of the unseen forces that govern the universe. Let your mind drift with this thought. Jupiter, spinning silently, a massive globe of gas and storms, its gravity reaching far across space, orchestrating the movements of planets, moons, comets, and asteroids. Its weight is a force felt throughout the solar system, a reminder of the power one planet can wield simply by existing. Next, we can explore the mysteries of Jupiter's atmosphere, where gravity, mass, and rotation combine to create the colorful bands, violent storms, and the faint glow of heat escaping from within. A realm that perfectly illustrates how a planet's mass shapes everything from clouds to magnetic fields. Jupiter's atmosphere is a swirling masterpiece, a vast expanse of gas shaped by the planet's immense mass, rapid rotation, and deep gravitational pull. Unlike Earth, Jupiter has no solid surface beneath the clouds, only layers of gas compressed under enormous pressure. What we see are the outermost layers, painted in stripes of browns, reds, and whites, each band moving in winds far faster than any hurricane on Earth. These bands are a direct consequence of the planet's size and rotation. Jupiter completes a full rotation in just under 10 hours, causing the equator to bulge and the clouds to stretch into long, parallel bands. Within these bands are storms of unimaginable scale. The Great Red Spot, a storm larger than Earth itself, has raged for at least 400 years. Its longevity is made possible by Jupiter's mass and energy. The planet generates more heat internally than it receives from the Sun. This internal heat drives convection, fueling powerful winds and creating stability in some storms even as others dissipate. Smaller storms swirl around, merging and splitting, dancing across the immense gaseous surface in patterns that are mesmerizing to observe. The atmosphere is layered. The topmost clouds are composed primarily of ammonia ice, reflecting sunlight and giving Jupiter its pale hues. Below these clouds are deeper layers of ammonium hydrosulfide and water ice, compressed by the weight of the gases above. Each layer exists under pressures and temperatures that increase rapidly with depth, a direct consequence of Jupiter's gravitational mass. At the core, hydrogen exists in a metallic state, conducting electricity and powering the planet's massive magnetic field. Gravity's role is crucial here. It compresses the atmosphere, forcing hydrogen into exotic states, shaping convection currents, and sustaining storms for centuries. It influences the motion of clouds, determining the boundaries of bands and the longevity of vortices. Jupiter's weight also maintains the atmosphere as a thick blanket of gas, far deeper and more massive than anything on Earth. The interplay of mass, rotation, and composition produces a dynamic, ever-changing world. Lightning flashes deep in the clouds, thunderstorms rage across bands, and auroras shimmer at the poles, energized by charged particles interacting with the magnetic field generated by the spinning metallic hydrogen core. Even the faint glow of Jupiter's internal heat escaping into space tells a story of immense mass holding enormous energy. Jupiter's atmosphere also demonstrates how a planet's mass shapes its moons. The gravitational pull from Jupiter affects the tides on moons like Europa and Io, generating heat and activity. Without Jupiter's mass, these moons would be far less dynamic, lacking volcanic eruptions or the subsurface oceans that may harbor the ingredients for life. Imagine watching Jupiter from above, seeing clouds swirl in endless bands, storms twisting and merging, lightning illuminating deep layers, and auroras dancing near the poles. This is a world where mass dictates motion, where gravity molds atmosphere, and where a single planet's presence dominates an entire system. The sheer scale of the atmosphere, the storms, and the motion of gases cannot be overstated. Jupiter's mass allows it to sustain phenomena that dwarf anything on Earth. Its weight presses layers of gas together, fuels storms that last centuries, and powers currents that circle the planet faster than any earthly winds. In this way, Jupiter's atmosphere is a living expression of its mass. Every cloud, every storm, every swirling stripe is a testament to the power contained in 318 Earth masses. The planet's presence is palpable, not just through numbers, but through motion, energy, and the dynamic beauty of its gaseous expanse. Beneath the swirling clouds and bands of Jupiter lies a realm hidden from sight, a world under pressure so immense that it challenges our imagination. This is the interior of Jupiter, where gravity, mass, and density converge to create a structure unlike any other planet in the solar system. While the outer layers may appear soft and gaseous, the heart of Jupiter is compressed by centuries of accumulated weight, forming an environment of extraordinary extremes. Scientists believe that at the very center of Jupiter lies a dense core, roughly 10 to 20 times the mass of Earth. This core is thought to be composed of rock, metals, and ices, materials that were among the first to coalesce during the planet's formation. Imagine taking 10 Earths, combining all their solid matter, and compressing it into a sphere deep within a gas giant. Even this is only a fraction of Jupiter's total mass. Surrounding this core, layers of hydrogen and helium, under pressures millions of times greater than Earth's atmosphere, are forced into states that do not exist naturally on our home planet. As we descend through Jupiter's layers, the familiar forms of matter begin to change. Hydrogen, normally a gas, is compressed by gravity until it becomes a metallic liquid, capable of conducting electricity and generating magnetic fields of staggering strength. This metallic hydrogen region may extend for tens of thousands of kilometers beneath the cloud tops. Picture a substance so dense and powerful that it is part liquid, part metal, yet invisible to the eye. This is a direct consequence of Jupiter's mass. The enormous gravitational pull compresses ordinary elements into extraordinary forms. The immense pressure and heat in Jupiter's interior create a planet that is still radiating energy long after its formation. In fact, Jupiter emits more energy than it receives from the Sun. Deep inside, heat from the planet's formation continues to escape slowly, fueling convection currents that drive the massive storms and jet streams visible in the atmosphere. This is heat stored from billions of years ago, maintained by the crushing weight of the planet itself. Every kilogram of hydrogen and helium, every pound of mass, contributes to this slow, inexorable release of energy. The structure of Jupiter's interior can be thought of as a series of concentric layers, each dictated by pressure and temperature. The outermost layer is composed of molecular hydrogen and helium, relatively cool and gaseous. Beneath this, hydrogen gradually becomes metallic as pressure rises, forming a thick, electrically conductive layer. The core lies at the center, shrouded by the dense metallic hydrogen, an unseen anchor around which the rest of the planet swirls. Gravity compresses each layer against the next, and the total mass of the planet ensures that these extreme conditions persist, unrelenting. At all depths, the gravity generated by this interior is immense. Even though Jupiter is mostly gas, the mass beneath the clouds produces a gravitational field more than twice as strong as Earth, at equivalent radii. This gravity is not merely a surface phenomenon, it shapes the planet from the inside out. It dictates the compression of hydrogen into metallic states, the flow of currents that generate the magnetic field, and the maintenance of storms that rage above. Jupiter's mass is the silent architect of its entire structure. Jupiter's interior also explains the extraordinary scale of its magnetic field. The combination of metallic hydrogen and rapid rotation creates a dynamo effect, generating a magnetic field 20,000 times stronger than Earth's. This field extends millions of kilometers into space, capturing charged particles and forming a magnetosphere that dwarfs all other planetary magnetic environments in the solar system. The mass of Jupiter allows for such a dense, conductive interior, and its rotation transforms that density into magnetic power. If we try to imagine descending through Jupiter, we would pass from familiar gas into strange metallic layers, into heat and pressure so intense that atoms themselves are compressed closer together than on Earth. There are no solid surfaces in the traditional sense, only layers of increasing density, each pressed harder than the last by the weight of everything above it. The planet's mass is responsible for these extremes, making Jupiter a world both massive and incomprehensible. Even more remarkable is that all this mass, all this pressure, exists in balance. Jupiter is massive enough to maintain metallic hydrogen and a dense core, but not massive enough to ignite fusion. It stands at the threshold of starhood, a failed star, carrying the potential for nuclear reactions that never begin. Its gravity, mass, and composition are in perfect equilibrium, allowing the planet to exist as the largest object in the solar system aside from the Sun, influencing every orbit, every moon, and every passing comet. Let your mind imagine the hidden interior of Jupiter, layers upon layers of gas and liquid under crushing pressure, metallic hydrogen flowing like an ocean of molten metal, heat escaping slowly through convection, and a dense, rocky core anchoring it all. Every cloud above, every storm we see, every magnetic particle trapped in the magnetosphere is ultimately a product of this interior, of this mass, of the gravitational force pressing inward from billions of kilograms of hydrogen and helium. Jupiter's interior is the engine of the planet, the source of its storms, its heat, its magnetic field, and its gravitational dominance. It is the hidden weight that governs not just the planet itself, but the motion of moons, the protection of inner planets, and the shaping of the solar system's architecture. Its mass is the ultimate storyteller, whispering the history of formation, the limits of size, and the delicate balance between being a planet and a star. Jupiter is not only the largest planet in the solar system, it is also the center of a vast family of moons and rings, each orbiting under the influence of the planet's immense gravity. To fully grasp the scope of Jupiter's mass, it is essential to explore how it governs these companions, creating a miniature cosmos in its own right. The planet's mass is the invisible hand that choreographs the movements, interactions, and evolution of this complex system. At the heart of this system are the four Galilean moons, Io, Europa, Ganymede, and Callisto. Discovered by Galileo in 1610, these moons are enormous worlds in their own right, some larger than Mercury, yet all are dwarfed by the gravity and mass of Jupiter. Each moon follows a path defined not only by its initial motion, but by the constant tug of Jupiter's mass. Their orbits are remarkably stable, shaped by resonance patterns that ensure they do not collide, yet the gravitational forces between them generate tidal heating and geological activity. Io, the innermost Galilean moon, is a volcanic powerhouse. Its surface is constantly reshaped by eruptions, driven not by internal radioactive decay alone, but by the tidal forces exerted by Jupiter's gravity. The enormous pull stretches and flexes Io as it orbits, generating heat in its interior that fuels the most active volcanism in the solar system. This is a direct consequence of Jupiter's mass. Without such a powerful gravitational influence, Io would be a quiet, frozen rock, instead of a world where lava flows and plumes of sulfur and ash rise into space. Europa, slightly smaller than Earth's moon, is another fascinating case. Its icy crust conceals a global ocean, potentially twice the volume of all Earth's oceans combined. The tidal flexing caused by Jupiter's gravitational tug keeps this ocean from freezing solid, maintaining the potential for chemical activity and perhaps even life. Once again, Jupiter's mass dictates the conditions on a distant moon, creating an environment impossible elsewhere in the solar system. Ganymede, the largest moon in the solar system, is massive enough to have its own magnetic field. Even so, it orbits under Jupiter's gravity, which dominates the dynamics of the system. Callisto, the outermost Galilean moon, is heavily cratered and ancient, a frozen witness to billions of years of bombardment. All four moons, despite their individual characteristics, owe their orbital stability, geological activity, and even internal heating to the pull of Jupiter's enormous mass. Beyond the Galilean moons are dozens of smaller satellites, each caught in Jupiter's gravitational web. These moons, irregular in shape and often captured asteroids, orbit in complex paths influenced by Jupiter's pull. Some follow prograde orbits, moving in the same direction as Jupiter's rotation. Others are retrograde, moving opposite to it. Each orbit, each path, is a delicate balance between the moon's own momentum and Jupiter's overwhelming mass. Without Jupiter's gravity, these moons would drift into the void, lost to space, but its presence holds them firmly in place, a cosmic shepherd keeping its flock together. Jupiter's influence extends even further to its faint, delicate rings. Unlike Saturn's wide, icy rings, Jupiter's are thin, dark, and composed mainly of dust. These rings are formed from particles ejected from moons, collisions with comets, and the constant bombardment of micrometeorites. The planet's gravity maintains the structure of these rings, confining the dust and shaping the trajectories of the particles. They are ephemeral in appearance, but they are real evidence of the reach of Jupiter's mass, a subtle yet constant expression of its gravitational dominance. The interaction of Jupiter with its moons also illustrates a larger principle. A planet's mass dictates its ability to sculpt its surroundings. The orbital resonances among the Galilean moons create cycles of motion, tidal heating, and even geological activity that would not exist without the giant planet's gravity. The moons are not merely orbiting passively. They are engaged in a dynamic dance orchestrated by Jupiter. Each volcanic eruption, each shifting ice sheet, each hidden ocean is a direct result of the immense pull of the giant world at the center. Even distant asteroids and comets feel Jupiter's reach. The planet acts as both guardian and destroyer, capturing or deflecting bodies that might otherwise wander into the inner solar system. Some objects are sent into tight orbits, becoming temporary satellites or ring particles. Others are slingshotted outward, sometimes into the distant Kuiper belt or even interstellar space. The very architecture of the solar system bears Jupiter's signature, and its moons and rings are the most visible evidence of this influence. Imagine floating above Jupiter, gazing at the tiny but vivid moons orbiting in precise paths, watching volcanic eruptions on Io, the icy sheets of Europa shifting imperceptibly, Ganymede's magnetic field shimmering, and Callisto's ancient surface standing as a testament to eons of cosmic history. Visualize the faint, dusty rings, nearly invisible but constant, each particle moving under the pull of a gravity so strong it controls all nearby matter. This is the true power of mass. It is invisible, yet omnipresent, shaping worlds, maintaining orbits, and creating dynamic environments on multiple levels. Jupiter's moons and rings remind us that mass is more than weight. It is influence, reach, and structure. Jupiter's enormous mass is not confined to the planet itself. It radiates outward, dictating the motions of moons, guiding the paths of asteroids, and even protecting Earth from countless potential collisions. Its mass is the central force in a miniature system, a tiny cosmos bound by gravity, where each moon's story is intertwined with that of the giant world it orbits. The moons themselves are reflections of Jupiter's presence, mirrors of its gravitational might. Io's fiery eruptions, Europa's liquid ocean, Ganymede's magnetic field, Callisto's ancient scars, and the countless smaller satellites are all shaped, maintained, and energized by the enormous mass of the planet at the center. Its rings, subtle and ephemeral, trace the delicate lines of gravity extending outward, a visual reminder of the planet's invisible power. Jupiter's influence extends far beyond its immediate moons and rings. Its enormous mass and gravity have shaped the solar system itself, a force so profound that Earth's safety and the very arrangement of the planets are tied to this giant. To understand Jupiter is to understand the role a massive planet can play not just in its own orbit, but in protecting and organizing an entire system. From the very beginning, Jupiter's mass determined the architecture of the solar system. As the planets formed from the primordial disk of gas and dust surrounding the newborn sun, Jupiter's gravity prevented certain regions from coalescing into planets. The asteroid belt between Mars and Jupiter exists because the giant's pull disrupted the accumulation of material. These countless rocks and debris were never allowed to join into a planet because Jupiter's weight perturbed their orbits, sending them colliding or scattering in chaotic paths. Without Jupiter, that belt may have formed into a planet, potentially altering the trajectory of Earth and the inner planets. Even today, Jupiter acts as a cosmic shield for Earth and the inner planets. Its massive gravity captures or redirects comets and asteroids that might otherwise pose a danger. Some are pulled into orbit around Jupiter itself, becoming temporary moons or adding to its faint rings. Others are slingshotted into distant space, removed from the inner solar system entirely. There are comets that, if not for Jupiter, might have collided with Earth, but instead are deflected or captured by the giant. In this sense, Jupiter is a protector, a silent guardian whose mass keeps potential catastrophes at bay. The mass of Jupiter also shapes the paths of distant objects. The orbits of some asteroids are in resonance with Jupiter, meaning their periods of revolution are exact fractions of Jupiter's orbital period. This gravitational choreography maintains order in regions that might otherwise be chaotic. Jupiter's pull stabilizes these objects, creating families of asteroids that follow predictable paths across the solar system. Even slight changes in Jupiter's mass or orbit would dramatically alter these patterns, sending asteroids and comets into new, potentially dangerous trajectories. Jupiter's role as a sculptor is even more profound in the outer solar system. The ice giants Uranus and Neptune, the distant Kuiper belt objects, and countless comets in the Oort cloud are influenced by Jupiter's gravity. It perturbs orbits, sometimes nudging comets toward the sun, sometimes sending them on elongated journeys into deep space. Jupiter's mass ensures that the solar system is not a random scattering of objects, but a structured and predictable system, where the gravitational influence of the giant guides the movement of planets, moons, and smaller bodies alike. Consider the story of long-period comets. These icy travelers, originating from the distant reaches of the Oort cloud, occasionally make their way toward the inner solar system. Without Jupiter's gravitational hand, some would plunge directly toward the Sun or the inner planets. Instead, many are deflected, captured temporarily, or sent back into the outer reaches, preserving the delicate balance of the inner solar system. In this way, Jupiter acts not only as a shield but also as a regulator, governing the flow of material across billions of kilometers of space. Even objects that pass near Jupiter can have their futures radically altered. A comet entering the giant planet's vicinity experiences tidal forces and gravitational slingshots. Its trajectory can change dramatically, sending it to distant regions, trapping it in orbit, or in rare cases, hurling it into the Sun. Jupiter's mass is the invisible hand that manipulates these cosmic wanderers, determining whether they survive, collide, or are ejected from the system entirely. The influence of Jupiter is also crucial in maintaining the stability of the inner planets. By capturing or redirecting potential threats, it has likely prevented countless catastrophic impacts on Earth. Imagine the countless comets and asteroids that have been deflected over billions of years, allowing life on our planet to flourish. Jupiter's mass and gravity have acted as a cosmic guardian, preserving the environment necessary for life to develop. Without this giant protector, Earth's history may have been dramatically different, punctuated by far more frequent and catastrophic collisions. Jupiter also maintains the delicate balance of the solar system's orbital architecture. Its mass affects the motion of Saturn, Uranus, and Neptune, helping to stabilize their orbits over billions of years. Slight shifts in Jupiter's mass or position could trigger cascading changes throughout the planetary system. The planets are interconnected through gravity, and Jupiter is the dominant force in this network. Its enormous mass ensures that the system remains ordered rather than chaotic. Visualize the solar system as a vast, cosmic dance. Jupiter is the lead dancer, massive and commanding, pulling other bodies into rhythm, shaping trajectories, and keeping the dancers from colliding. Its moons circle in perfect patterns, comets twist along paths guided by its pull, and asteroids align in resonances created by its weight. Even the inner planets, including Earth, move along stable orbits thanks to this giant's gravitational influence. Jupiter's mass is not simply a number. It is the structural spine of the solar system, the anchor that keeps billions of objects moving in harmony across billions of kilometers of space. In this role, Jupiter is both protector and sculptor. It prevents chaos, shields life on Earth, and shapes the orbits of countless objects. Its mass governs not just its own system of moons and rings, but the entire neighborhood, from the inner planets to the distant icy bodies at the edge of the Sun's influence. It is a cosmic architect, a sentinel, and an orchestrator. Let your mind drift with this vision. A giant planet spinning silently in the void, its gravity stretching across millions of kilometers, capturing, deflecting, and guiding, shaping a solar system in ways invisible yet profound. Jupiter's mass is not a passive weight. It is an active force, sculpting motion, creating stability, and ensuring that the planets dance in order rather than chaos. Every asteroid redirected, every comet captured, every orbit maintained is a testament to the power of this immense world. Jupiter's atmosphere is a dynamic, turbulent realm, a world where storms rage on a scale that dwarfs anything on Earth. These storms, winds, and electromagnetic phenomena are not random. They are powered and maintained by the sheer mass of the planet, which drives internal heat, rotation, and the movement of gases. To understand Jupiter's weather is to understand how a massive planet can sustain motion and energy on scales almost impossible to imagine. At the heart of these phenomena is the rapid rotation of Jupiter. Despite its size, over 140,000 kilometers in diameter, the planet completes a full rotation in just under 10 hours. This rotation, combined with the immense mass pressing down from above, generates powerful Coriolis forces. These forces organize winds into long, parallel jet streams, which appear as the distinct bands we see from Earth. The alternating dark belts and light zones are moving at hundreds of kilometers per hour, some reaching speeds over 600 kilometers per hour, far faster than the strongest hurricanes on Earth. Jupiter's mass compresses the gases beneath the clouds, providing the energy and pressure needed to sustain these winds over centuries. The Great Red Spot is the most famous of Jupiter's storms, a hurricane larger than Earth that has persisted for at least 400 years. Its longevity is a direct result of Jupiter's mass and internal heat. Deep convection currents, driven by energy escaping from the planet's interior, fuel the storm and prevent it from dissipating. The swirling gases of the Great Red Spot rotate at incredible speeds, creating complex turbulence and vortex patterns. Smaller storms frequently merge with or are absorbed by this giant vortex, maintaining its energy over centuries. Imagine a storm so vast that Earth could fit comfortably inside, yet it moves continuously, powered by energy stored deep within the planet's massive core. Jupiter's mass also allows for lightning and electrical phenomena on an unprecedented scale. Within the thick clouds, ammonia and water form layers where convection causes charge separation, resulting in lightning bolts far more powerful than those on Earth. Some of these bolts stretch for hundreds of kilometers, illuminating the dense clouds in brilliant flashes. The combination of mass, pressure, and rotation sustains this electrical activity, creating an energetic and dynamic atmosphere. Beneath the clouds, the planet's interior is equally active. The metallic hydrogen layer, created by the enormous pressure of Jupiter's mass, conducts electricity and drives the planet's magnetic field. This field is immense, 20,000 times stronger than Earth's, and extends millions of kilometers into space. Charged particles from the solar wind become trapped in the magnetosphere, forming radiation belts of incredible intensity. These belts interact with the atmosphere, fueling auroras at the poles that are far more powerful than Earth's northern and southern lights. Here, mass and rotation work together to generate both motion and electromagnetic energy. The winds, storms, and magnetic phenomena are interconnected. The mass of the planet compresses hydrogen into metallic states, powering the dynamo that generates the magnetic field. The internal heat drives convection currents in the atmosphere, which creates storms and jet streams. The rotation organizes these currents into bands and vortices, while the magnetic field interacts with charged particles to produce auroras and radiation belts. Every motion, every flash of lightning, every magnetic ripple is a consequence of Jupiter's enormous mass. Even the smaller, transient storms on Jupiter demonstrate the influence of mass. White ovals, brown barges, and miniature vortices appear, merge, and dissipate across the bands, all guided by the planet's gravitational and rotational forces. Their behavior is dictated by the weight pressing from above and the energy flowing from below, a perfect example of how mass can generate and sustain dynamic motion on a planetary scale. Jupiter's mass also influences its atmosphere's depth and density. Clouds extend for hundreds of kilometers, and beneath them lies a thick layer of gas compressed by gravity. The deeper you go, the more extreme the pressure becomes, forcing gases into unusual states and sustaining energy flows that power the storms above. Every storm is a surface expression of the mass beneath, a visible sign of the weight and energy contained in the planet's interior. Visualize Jupiter from orbit. Swirling bands stretch across the globe, winds whipping in opposite directions along parallel paths. The Great Red Spot spins endlessly, while smaller storms dance around it. Lightning flashes in deep clouds, illuminating towering storms. At the poles, auroras shimmer in colors far brighter and more intense than Earth's northern lights. Invisible yet immense, the magnetic field reaches into space, capturing charged particles, forming radiation belts and interacting with the moons. This entire spectacle, every storm and flash, is powered by the mass of a single planet. In this sense, Jupiter is not merely a world. It is a living, dynamic system, energized by its weight, shaped by its gravity, and sculpted by its rotation. Its storms, winds, lightning, and magnetic phenomena are all expressions of the same fundamental reality: 318 Earth masses compressed into a rotating, spinning giant. The energy and motion we observe are the direct consequences of the mass, demonstrating how a planet can be both static in weight and dynamic in expression. Jupiter's story is not limited to its present. Its enormous mass ensures that it will continue to shape the solar system for billions of years to come. The gravitational influence of this giant extends far beyond its immediate moons and rings, touching the orbits of asteroids, comets, and even the inner planets. Jupiter is both a stabilizing force and a cosmic sculptor, and its long-term presence has profound consequences for the evolution of the entire planetary system. The asteroid belt, located between Mars and Jupiter, owes much of its current form to the planet's gravity. Billions of years ago, this region was filled with rock and ice, remnants of the solar nebula that had failed to coalesce into a planet. Jupiter's mass exerted a constant pull, disrupting the motions of these bodies and preventing them from forming a single planetary body. Over time, its gravitational influence created gaps in the belt, known today as Kirkwood gaps, where asteroids are scarce because Jupiter's gravity destabilizes their orbits. The asteroid belt as we see it today is a testament to the enduring power of Jupiter's mass, a structure shaped and maintained over eons by the pull of a single planet. Jupiter also protects the inner planets, including Earth, from frequent catastrophic impacts. Its gravity captures or deflects comets and asteroids that might otherwise cross into the inner solar system. Some are drawn into orbit around Jupiter itself, becoming temporary moons or adding to the faint rings, while others are slingshotted outward, sent into distant regions of the solar system, or even ejected entirely. Without Jupiter's protective influence, Earth might have endured far more frequent collisions, potentially altering the course of life's evolution. In this sense, Jupiter acts as a long-term guardian, its mass a shield extending across millions of kilometers. The giant planet also shapes the orbits of distant objects in the Kuiper belt and Oort cloud. Comets originating from these far reaches are sometimes nudged by Jupiter into elongated trajectories, bringing them toward the inner solar system, while others are captured into temporary orbits or redirected entirely. This gravitational influence ensures a level of order in a system that could otherwise be chaotic. Jupiter's mass governs not only the present arrangement of objects, but the flow of matter across billions of kilometers, influencing the solar system on timescales far beyond a human lifetime. Over millions and billions of years, Jupiter's gravity will continue to sculpt the planetary system. Its presence stabilizes Saturn's orbit, affects the motion of Uranus and Neptune, and maintains the delicate balance among countless smaller bodies. Slight changes in Jupiter's mass or orbit could ripple across the solar system, altering asteroid paths, cometary trajectories, and even the long-term stability of Earth's orbit. Its mass is not simply weight. It is a stabilizing force, a cosmic regulator that ensures the solar system remains organized rather than chaotic. Jupiter's influence may also play a role in the distant future, during interactions with other stellar systems or the eventual evolution of the Sun. As the Sun ages and expands into a red giant, the gravitational relationships within the solar system will shift. Jupiter, by virtue of its mass, will remain a dominant force, determining the fates of many planets and smaller bodies. Some moons and asteroids may be captured or ejected, and the arrangement of the outer solar system could be radically transformed. Even as the Sun fades and changes, Jupiter's mass will continue to dictate the motion and evolution of its companions. Consider the long-term influence on comets and icy bodies. Objects that currently reside in the distant Oort cloud may, over millions of years, drift inward, interacting with Jupiter's gravity. Some may be captured temporarily, some ejected into interstellar space, and others directed toward the inner planets. Jupiter's mass acts as a filter and guide, shaping the trajectories of countless objects across the solar system. Its gravitational reach is truly cosmic in scale, extending influence over billions of kilometers and billions of years. Jupiter's role in stabilizing the solar system also highlights the delicate balance of planetary mass and distance. Without a planet of such size and gravity at its current position, the inner planets, including Earth, might experience far greater instability. Orbital resonances, asteroid impacts, and cometary encounters could increase dramatically. Jupiter's mass ensures a harmony among the planets, a gravitational choreography that has persisted for more than 4 billion years and will continue long into the future. Visualize the solar system across deep time. Jupiter, spinning in its orbit, exerts a constant pull, guiding the dance of planets, moons, asteroids, and comets. Its mass is the invisible force that maintains order, protects worlds, and shapes the long-term evolution of the system. Each asteroid prevented from striking Earth, each comet redirected into the outer solar system, each orbital resonance maintained is a subtle yet powerful testament to the influence of this giant planet. Jupiter is more than a planet. It is the guardian and architect of the solar system. Its mass dictates motion, shapes structure, and preserves stability over billions of years. From the inner planets to the distant edges of the Oort cloud, Jupiter's gravitational influence reaches everywhere, a silent yet unyielding presence shaping cosmic history. Its enormity is not just a matter of scale, it is a matter of control, order, and enduring power. Jupiter's story is not confined to the solar system alone. Its enormous mass, immense gravity, and position as the giant of our planetary neighborhood mean that it will play a role in the destiny of our system as it journeys through the galaxy. In the distant future, billions of years from now, the Milky Way galaxy itself will collide with the Andromeda galaxy, a cosmic event of unimaginable scale. In this grand ballet of stars, planets, and gas clouds, Jupiter's mass will continue to influence the fate of its moons, the Sun, and even Earth. The collision of two galaxies might sound chaotic, but on the scale of individual stars and planets, the interactions are surprisingly subtle. Stars are separated by such vast distances that direct collisions are rare. However, the gravitational effects of billions of stars moving toward one another will dramatically alter the orbits of stars and planetary systems. Within this context, Jupiter's mass is a stabilizing force for the solar system. It will help maintain the orbits of planets and moons even as the Sun's position in the galaxy changes. The immense gravitational pull of this gas giant acts like an anchor, keeping the inner planets, orbits more stable than they might otherwise be during such a colossal event. Jupiter will continue to shepherd comets and asteroids, even as the solar system experiences gravitational perturbations caused by the galactic merger. Some distant icy bodies may be nudged inward toward the Sun or outward into interstellar space, but Jupiter's mass ensures that many are captured, redirected, or stabilized within the system. Its role as a cosmic guardian extends not only across billions of kilometers, but across billions of years, enduring even galactic-scale events. The Sun itself may be affected by the Milky Way-Andromeda collision, possibly moving into new regions of space with altered stellar neighbors. This may change the influx of comets and interstellar objects into the solar system. Jupiter, massive and commanding, will continue to dominate these dynamics, deflecting potential threats, capturing errant bodies, and maintaining the delicate balance of the planets. Even in a universe undergoing dramatic structural changes, Jupiter's mass provides continuity, order, and protection. The collision of galaxies may also trigger the creation of new star systems, and some of these gravitational interactions could subtly influence the solar system's path. Jupiter's massive gravity will help preserve the overall architecture of its system, stabilizing planets and moons against long-term disturbances. Its magnetic field, driven by metallic hydrogen deep within its core, will continue to shield its moons from charged particles and cosmic radiation, preserving their environments even as the galaxy around them shifts. Consider the moons of Jupiter in this scenario. Europa's subsurface ocean, Io's volcanic activity, Ganymede's magnetic field, and Callisto's ancient, icy surface. All of these worlds will continue their intricate dances around the giant planet, influenced more strongly by Jupiter than by distant galactic events. Jupiter's mass ensures that the motions of these moons remain predictable, that tidal heating continues, and that the delicate balance of forces within this system persists. Even when stars and planetary systems elsewhere in the galaxy are drawn into new orbits, the solar system's internal dynamics, led by Jupiter, remain remarkably stable. In this far-future vision, Jupiter exemplifies how mass defines endurance and influence. While stars may shift, galaxies may collide, and comets may wander, Jupiter's enormous mass and gravity act as a stabilizing anchor, a cosmic constant amidst galactic chaos. It is a reminder that mass is not merely a number. It is power, influence, and the ability to shape destiny on scales both planetary and galactic. Visualize the scene. Billions of years from now, the Milky Way and Andromeda merging, stars shifting and rearranging across the sky. The Sun's position in the galaxy subtly altered, yet within the solar system, Jupiter remains the steadfast giant. Its gravity holds the moons in orbit, deflects comets, stabilizes planetary paths, and maintains the delicate architecture of a system enduring cosmic upheaval. Its storms rage, its magnetic field hums, and its mass continues to dictate motion, energy, and structure, just as it has for billions of years. Jupiter's future role is a testament to its enduring influence. The solar system may drift through the changing galaxy, but the presence of the massive gas giant ensures continuity, safety, and order. It protects, it stabilizes, and it shapes the destiny of planets and moons, all while spinning silently in space, a colossus whose gravitational power extends far beyond its immediate surroundings, even as the universe evolves on scales far larger than human comprehension. Jupiter's mass guarantees that it remains a central figure in the story of the solar system. Its influence is timeless, a bridge between the present arrangement of worlds and the future evolution of the galaxy itself. Through storms, magnetic fields, moons, and orbital stability, Jupiter demonstrates that mass is not only matter, it is authority, continuity, and cosmic resilience. Jupiter's story is not only about its present size and power, it is also about the slow, inexorable changes that will unfold over billions of years. Despite its apparent permanence, Jupiter, like all planets, is subject to the forces of time, energy loss, and cosmic evolution. Its immense mass, while stabilizing its system and powering storms and magnetism, also dictates how it will age, cool, and evolve into the distant future. At the heart of Jupiter lies its dense core, surrounded by layers of metallic hydrogen and gaseous envelopes. Over billions of years, the internal heat left from the planet's formation will gradually radiate into space. Even now, Jupiter emits more energy than it receives from the Sun, a relic of gravitational compression and heat trapped since the birth of the solar system. This internal energy fuels storms, jet streams, and convection, but over immense timescales, it will slowly decline. As Jupiter cools, the dynamics of its interior may change. The metallic hydrogen layer may contract slightly, altering convection currents and potentially influencing the magnetic field generated by the planetary dynamo. The magnetic field, powered by metallic hydrogen circulating in Jupiter's deep interior, may weaken over eons. The immense mass of the planet ensures that the dynamo continues to function for an extraordinarily long time, but gradual cooling could eventually reduce the vigor of the flows that sustain it. A weaker magnetic field would subtly change the behavior of the magnetosphere, the trapping of charged particles, and the intensity of auroras at the poles. Even so, Jupiter's mass is so immense that these changes would occur on timescales far beyond human comprehension, millions, or even billions of years. The composition and structure of the atmosphere will also evolve. Hydrogen and helium dominate the gaseous envelope, but over extreme timescales, diffusion and gradual escape of lighter elements could alter the relative proportions of gases. Convection currents may slow as internal heat diminishes, potentially reducing the scale and intensity of storms like the Great Red Spot. The iconic bands of the atmosphere, which have persisted for centuries, may eventually shift or fade, but the planet's mass ensures that the overall structure, a deep, layered gaseous envelope surrounding a dense core, remains intact. Jupiter's moons will continue to orbit under its gravitational pull, but over billions of years, tidal forces may subtly alter these orbits. Europa's subsurface ocean, heated by tidal flexing, may gradually cool as energy from these interactions is dissipated. Io's volcanic activity could diminish as tidal energy declines, leaving a quieter, less geologically active moon. The interplay between Jupiter's mass and the energy it imparts to its moons ensures that these changes occur slowly, preserving the system's structure over eons. Even as the Sun ages, swelling into a red giant and eventually shedding mass, Jupiter's mass ensures that it remains the dominant planet in the outer solar system. Its gravitational pull will preserve the orbits of remaining planets and moons, and it will continue to capture or deflect comets and asteroids. Its protective role may become even more critical if solar winds and radiation increase during the Sun's later stages. Jupiter's mass guarantees that it remains the anchor of the solar system, maintaining order long after smaller planets have been affected by solar evolution. Eventually, over timescales measured in tens or hundreds of billions of years, Jupiter will continue to cool and fade. It will never ignite as a star. Its mass, though enormous, is insufficient to trigger nuclear fusion. Instead, it will become a colder, slower-moving giant, a silent sentinel in space. The storms and auroras that once dazzled observers may diminish, the magnetic field may weaken, and the atmospheric bands may blur, but its core, compressed and massive, will remain a formidable presence. Its gravity will continue to hold its moons, and its mass will continue to influence the orbits of distant bodies. Imagine a distant future, when Jupiter is no longer the vibrant, storm-filled giant we see today. Its clouds may appear darker, its storms quieter, its magnetic energy reduced, yet its sheer mass continues to dominate. The moons orbit faithfully, small fires of energy from tidal interactions gradually waning. The solar system drifts through the galaxy, its planets guided by the enduring gravity of the giant at its heart. Even in this quiet, cooled state, Jupiter's presence is felt. Its mass is the defining characteristic, a constant through time, shaping motion, stability, and cosmic architecture. In essence, Jupiter's mass is both its power and its legacy. It drives storms, fuels magnetic fields, anchors moons, protects the inner planets, sculpts the solar system, and preserves stability across billions of years. Even as time gradually cools its core and quiets its atmosphere, the influence of this massive planet will echo through the cosmos. Jupiter is a testament to how mass can dictate not just the present, but the long-term destiny of an entire system, through all stages: formation, present dynamics, interactions with moons, influence over the solar system, and eventual cooling. Jupiter's enormity remains the defining feature. Its mass is not simply a number. It is the engine of motion, the anchor of stability, and the architect of cosmic order. For billions of years to come, this massive world will continue to govern the dance of planets, moons, asteroids, and comets, a silent yet commanding presence in the galaxy. Even though Jupiter is the most studied planet after Earth, its sheer size and mass ensure that vast mysteries remain hidden deep within. Beneath the swirling clouds and raging storms lies a world we have yet to fully understand. Its enormous mass compresses hydrogen into metallic states, drives powerful magnetic fields, and creates extreme pressures that are impossible to replicate on Earth. These conditions make Jupiter a natural laboratory for physics, chemistry, and planetary science, and they remind us that mass is not only influence. It is the key to unlocking phenomena beyond human imagination. One of the deepest mysteries lies at the planet's core. Observations from missions like Juno have revealed that Jupiter may not have a simple, solid core. Instead, it could have a diluted or partially dissolved core, where heavy elements are mixed with metallic hydrogen and helium. The exact structure is uncertain, but Jupiter's massive gravity compresses these materials to pressures millions of times greater than those on Earth. Studying this interior challenges our understanding of matter under extreme conditions. How do elements behave when crushed by such weight? How does the metallic hydrogen layer move, generate magnetic fields, and interact with the core? These questions remain at the forefront of planetary science. Metallic hydrogen itself is a profound mystery. This exotic form of hydrogen, created under the immense pressure of Jupiter's mass, behaves like a metal, conducting electricity and powering the planet's massive magnetic field. Laboratory attempts to replicate metallic hydrogen on Earth have only partially succeeded, and the behavior of this substance deep inside Jupiter is still largely theoretical. Its movement generates the dynamo that sustains the magnetic field, while the mass of the planet keeps it under extreme pressure. Understanding metallic hydrogen could unlock insights not only about Jupiter, but about other gas giants, exoplanets, and even fundamental physics. Jupiter's moons also hold hidden secrets. Europa's subsurface ocean may harbor conditions suitable for life, yet the icy crust conceals its depths. Ganymede's magnetic field is unique among moons, and Callisto's ancient surface records eons of cosmic history. Io's volcanism is powered by tidal heating, an energy source directly tied to Jupiter's mass. Each moon is a puzzle, and Jupiter's gravity is the key that links their dynamics, shapes their geology, and potentially sustains environments that may surprise us in the future. Beyond the known moons, there may be undiscovered or transient satellites, too small or too distant to detect easily. Jupiter's gravitational reach extends far beyond the familiar Galilean moons. Tiny, irregular bodies may orbit the giant, captured asteroids or remnants from the early solar system. Some could be temporary, gradually falling into the planet or being ejected into space. Jupiter's mass determines the stability and lifetime of these orbits, and the discovery of even a single new moon would add to our understanding of how gravity shapes planetary systems. Jupiter also hides mysteries in its atmosphere. While we can observe the upper cloud layers, the deeper regions remain inaccessible to direct measurement. Complex chemical reactions occur under extreme pressure, possibly producing exotic compounds or unexpected weather phenomena. The enormous mass compresses gases to depths where temperatures and pressures are far beyond Earth's experience, creating conditions where hydrogen, helium, and other elements interact in ways we are only beginning to theorize. Even its magnetic environment contains unknowns. Jupiter's magnetosphere is enormous, extending millions of kilometers into space, and it interacts with the solar wind, charged particles, and the moons in complex ways. Auroras at the poles reveal some of this activity, but the full dynamics are far more intricate. The mass of Jupiter drives these processes, and the scale of its magnetosphere dwarfs Earth's, creating radiation belts that are deadly to spacecraft and mysterious in their structure. Understanding the full extent of Jupiter's magnetic influence is a frontier of space science. Consider the future missions planned to explore these mysteries. Probes like ESA's JUICE and NASA's Europa Clipper will dive into the moon's oceans, magnetic fields, and atmospheres, seeking to answer questions about habitability, magnetic interactions, and tidal dynamics. Each observation will deepen our understanding of how Jupiter's mass controls its system, fuels motion, and creates environments that may harbor life. Even after decades of study, Jupiter remains a world of wonder, where every discovery leads to new questions. Visualize this colossal planet as both known and unknown. Its swirling storms, powerful magnetic fields, and orbiting moons are visible and measurable. Yet beneath, In the crushing pressures of metallic hydrogen and a potentially diluted core, secrets remain. Its mass is the defining factor in all of these phenomena, compressing, heating, and energizing the planet. Jupiter is a reminder that even in our own cosmic backyard, the largest worlds hold mysteries far beyond what we can imagine. In essence, Jupiter's mass is the key to everything we see and everything we have yet to discover. It powers storms, sustains magnetic fields, stabilizes moons, protects the inner planets, and governs the long-term evolution of the solar system. And yet, it also conceals secrets, holding within it phenomena that challenge our understanding of physics, chemistry, and planetary science. The more massive a planet, the more profound its mysteries. Jupiter, in all its enormity, is a living testament to that truth. Jupiter is the undisputed giant of our solar system, but it is also a benchmark against which we measure other planets, both nearby and across the galaxy. Its mass, approximately 318 times that of Earth, sets it apart from all other planets in the solar system and gives it characteristics that are difficult to match. By comparing Jupiter to Saturn, Uranus, Neptune, and even distant exoplanets, we can understand how mass shapes planetary structure, atmosphere, magnetism, and evolution. Saturn, the second largest planet in our system, is only about one-third as massive as Jupiter. Its famous rings captivate observers, but Saturn's lower mass means it cannot compress hydrogen into metallic forms as extensively as Jupiter does. Its magnetic field is weaker, its storms less powerful, and its ability to influence the solar system comparatively limited. Jupiter's mass dominates the outer solar system, controlling not only its moons, but also shaping the asteroid belt, comets, and orbital resonances in ways Saturn cannot. Where Saturn wields elegance and beauty, Jupiter wields strength and stability. Uranus and Neptune, the ice giants, are smaller still. Uranus has only about 14 Earth masses, Neptune about 17. Their compositions differ, with heavier elements and ices playing a greater role, and their atmospheres are less dominated by hydrogen and helium. The storms on Neptune can be intense, but they are fueled differently, with less contribution from internal heat compared to Jupiter. The gravitational influence of Uranus and Neptune is localized to the outer reaches, while Jupiter's mass governs much of the solar system. In this sense, Jupiter is the anchor, while the ice giants are the distant dancers, influenced by the giant's pull rather than commanding it. Beyond the solar system, astronomers have discovered thousands of exoplanets, some of which rival or exceed Jupiter's mass. Hot Jupiters are gas giants that orbit extremely close to their stars, sometimes completing a full orbit in just a few days. These planets are exposed to intense radiation, tides, and stellar winds. Yet they are massive enough to retain their thick hydrogen-helium atmospheres. Comparing them to Jupiter shows how mass can dictate a planet's survival in extreme conditions. While Jupiter orbits at a safe distance, preserving its moons and maintaining stability, hot Jupiters survive in hostile environments primarily because of their mass. Mass, once again, is the defining factor in planetary resilience. Even more massive exoplanets, sometimes called superjupiters, push the boundaries of what we understand about planetary physics. Some are 10 times the mass of Jupiter, approaching the limit before hydrogen fusion begins and the object becomes a brown dwarf. These extreme cases demonstrate that as mass increases, internal pressure, metallic hydrogen layers, magnetic fields, and gravitational influence scale dramatically. Jupiter, while enormous, occupies a sweet spot, massive enough to dominate its system and sustain incredible dynamics, yet far below the threshold of nuclear fusion. It is the perfect example of a gas giant, a standard against which astronomers measure other worlds. The comparison highlights another truth: mass shapes everything about a planet. A planet's size, its gravity, the depth of its atmosphere, the strength of its magnetic field, the intensity of its storms, and its ability to influence surrounding objects, all depend on how massive it is. Jupiter's mass allows it to spin rapidly, sustain long-lived storms, maintain a powerful magnetosphere, and dominate the orbital dynamics of the solar system. Its moons, rings, and nearby asteroids are all products of the planet's weight and gravity. Without this mass, Jupiter would not be Jupiter. It would be a smaller, weaker planet, unable to serve as the cosmic anchor we observe today. By studying Jupiter and comparing it to other planets, we gain insight into planetary formation, evolution, and the diversity of worlds in the universe. It teaches us how mass governs not just physical characteristics, but also the long-term dynamics of entire systems. Whether examining Saturn's elegance, Neptune's icy winds, or the scorching hot Jupiter's orbiting distant stars, Jupiter remains the reference point, a massive, stable, and awe-inspiring example of what a gas giant can be. Visualize Jupiter in this cosmic context. Its bands, storms, magnetosphere, and moons are not just features of a single planet. They are benchmarks, standards of planetary power, resilience, and influence. Across the galaxy, astronomers see echoes of Jupiter in distant exoplanets, yet few can match its combination of mass, distance from its star, and long-term stability. Its enormity is not simply about size. It is about dominance, endurance, and the capacity to shape everything around it. Jupiter is more than a planet. It is a cosmic monument to scale, mass, and enduring influence. When we observe its swirling storms, orbiting moons, and invisible gravitational reach, we are confronted with the profound contrast between human experience and the vastness of the universe. The enormity of Jupiter reminds us of time, power, and the enduring forces that shape existence on scales far beyond our comprehension. To reflect on Jupiter is to reflect on scale. Consider the size of this giant, over 11 times the diameter of Earth, 318 times its mass, and hundreds of times its volume. Its gravity is not merely a number. It shapes the motions of countless objects, sculpts the asteroid belt, and maintains the orbits of moons across millions of kilometers. This is a scale that challenges human imagination, yet it is tangible in its effects. We feel the contrast between our tiny lives and the grandeur of a planet that dominates its system, a reminder that the universe operates on laws and forces far beyond our everyday experience. Time itself is reflected in Jupiter. Its storms, like the Great Red Spot, have persisted for centuries. Its magnetic field and gravitational influence extend billions of years into the past and future. Observing Jupiter invites meditation on endurance, on processes that unfold slowly across epochs. Humanity is young in comparison. Civilizations rise and fall, yet Jupiter continues, spinning in space, its mass guiding motion and stability. Its presence is a measure of cosmic patience, a reminder that some forces endure far longer than human lifetimes. Jupiter also inspires reflection on order amidst chaos. Its storms are turbulent and violent, yet contained within bands and vortexes shaped by rotation and gravity. Its moons orbit faithfully, bound by the invisible pull of mass. Its influence organizes the solar system, directing comets, stabilizing planets, and creating patterns that endure for billions of years. In Jupiter, we see a metaphor for balance. Forces that might seem chaotic are structured and ordered by the fundamental power of mass. It reminds us that even in vast, complex systems, stability can emerge from overwhelming energy and motion. The enormity of Jupiter prompts contemplation of humanity's place in the cosmos. Standing beneath its imaginary shadow, imagining the swirling clouds and storms larger than Earth itself, we recognize our smallness, yet also our capacity for understanding. Through telescopes, spacecraft, and scientific inquiry, humans grasp the nature of this massive planet. Our ability to measure, model, and reflect on Jupiter's influence is a testament to curiosity and intellect, even in the face of cosmic immensity. The giant teaches humility, awe, and the joy of discovery. Jupiter's mass also invites reflection on energy and transformation. Its interior heat, storms, and magnetic fields demonstrate how mass converts gravitational pressure into motion, light, and magnetism. The universe is dynamic, and Jupiter exemplifies this truth. Matter, compressed and massive, becomes energy, motion, and influence. Observing this interplay allows meditation on forces that shape reality, on energy hidden in weight and pressure, and on the subtle ways that scale and mass govern the unfolding of the cosmos. Finally, Jupiter evokes a sense of cosmic continuity. It has existed for billions of years, and its mass ensures it will persist for billions more. Its influence spans from the innermost asteroid belt to the distant edges of the Oort cloud. Its presence links past, present, and future, offering a tangible thread of stability in a universe of change. In contemplating Jupiter, we are reminded that some forces are eternal on human timescales, that scale and mass confer not just power but a kind of immortality in cosmic terms. Visualize a quiet moment. The solar system drifts through space, the sun illuminating Jupiter's swirling clouds. Storms rage gently in the distance, auroras shimmer at the poles, and moons glide silently through orbit. Invisible gravitational currents stretch across the system, orchestrating motion and stability. Jupiter spins, massive and enduring, a silent guardian and sculptor, a testament to the power of mass and time. Its presence invites reflection, meditation, and awe, a perfect companion for thoughts that wander toward the infinite. In this sense, Jupiter is both a scientific wonder and a philosophical guide. It teaches us humility, patience, and reverence for forces larger than ourselves. It reminds us that scale, mass, and time are interconnected, and that the universe is vast, ordered, and beautiful. Observing and contemplating Jupiter becomes a form of cosmic meditation, a calming, reflective experience where science and philosophy merge, and where the enormity of a single planet can inspire wonder, contemplation, and serenity. While Jupiter is famous for its great red spot, colossal storms, and massive moons, it also has subtle features often overlooked, its faint rings and dozens of smaller, irregular moons. These aspects may seem minor compared to its enormity, yet they reveal important details about the planet's mass, gravitational influence, and ongoing evolution. Jupiter's rings are faint, thin, and composed primarily of dust particles, likely originating from impacts on its moons. Unlike Saturn's prominent icy rings, Jupiter's rings are difficult to observe, yet they exist as evidence of the constant interactions between the planet's mass and surrounding material. Micrometeoroid impacts on moons like Medes and Adrastea eject dust into orbit, where Jupiter's gravity captures it, creating the delicate, barely visible ring system. This process demonstrates how the planet's mass continually shapes the environment around it, even in subtle ways. Jupiter also hosts dozens of lesser-known moons, many irregular in size, shape, and orbit. These distant satellites are often captured asteroids or remnants of collisions, their fates determined by Jupiter's gravitational field. Some orbit in retrograde motion, moving opposite to the planet's rotation, a clear testament to the dynamism imposed by Jupiter's mass. Each small moon, from Amalthea to Themisto, contributes to the complexity of the system, reflecting the subtle yet pervasive influence of the giant planet. Even the smallest moons are affected by Jupiter's tidal forces, which can shape surfaces, generate internal heat, or alter orbital paths over millions of years. The interplay of mass, gravity, and motion creates a miniature dance of celestial bodies, highlighting the enormous reach of Jupiter's influence. Though less dramatic than the storms or magnetic field, these subtle features complete the picture of Jupiter as a planet whose mass dictates structure, motion, and cosmic relationships in ways both grand and delicate. Jupiter's mass may make it inhospitable, but it plays a critical role in the potential for life in its system, especially on moons like Europa, Ganymede, and Callisto. Its gravitational pull generates tidal forces that heat interiors, sustain oceans beneath icy crusts, and drive geological activity, conditions that might allow life to exist in environments far removed from Earth. Europa, with its vast subsurface ocean, is particularly intriguing. Jupiter's mass and gravity create tidal flexing, generating heat that keeps liquid water from freezing solid. Cracks in the icy crust hint at the movement of water beneath, and the energy provided by Jupiter's gravity could sustain chemical reactions essential for life. Similarly, Ganymede's internal ocean, combined with its magnetic field, might provide protective shielding from radiation, while Callisto's ancient surface preserves a record of cosmic events influenced by Jupiter's mass. Even Jupiter itself, while a gas giant, may indirectly support life by protecting the inner solar system from frequent catastrophic impacts. Its gravitational dominance captures or deflects comets and asteroids, reducing the likelihood of devastating collisions on Earth or Mars. In this sense, the mass of Jupiter indirectly sustains the conditions necessary for life closer to the Sun, highlighting its role as both guardian and enabler in the broader context of habitability. The search for life in Jupiter's system is ongoing, driven by missions such as NASA's Europa Clipper and ESA's JUICE. Scientists hope to analyze ice plumes, magnetic interactions, and surface composition to understand whether Jupiter's mass-driven tidal heating has created environments capable of supporting living organisms. The enormity of Jupiter thus becomes a paradoxical enabler, too massive to be habitable itself, yet massive enough to foster potential life on its moons and protect life in the inner solar system. As we bring our journey around Jupiter to a close, we pause to reflect on the enormity, majesty, and quiet power of this giant planet. Jupiter is more than a collection of gas, storms, moons, and magnetic fields. It is a cosmic monument to mass, influence, and enduring presence. From the faintest dust ring to the great red spot, from Europa's hidden oceans to the distant reaches of the Oort cloud, Jupiter's mass shapes motion, energy, and stability across the solar system. Imagine the planet spinning slowly in the darkness of space, its clouds forming endless bands of color, swirling storms raging with energy drawn from its massive interior. Its magnetic field hums invisibly, channeling charged particles in arcs of light, creating auroras that shimmer over the poles. Moons glide silently through orbit, some volcanic, some icy, some hiding oceans beneath frozen crusts. Even the smallest dust grains, the faint rings, and the captured asteroids are all held in a delicate balance by Jupiter's gravitational command. Jupiter's mass is the defining force, the invisible thread connecting storms, moons, rings, and even the inner planets. Its influence stabilizes the solar system, shields Earth from potential impacts, and guides comets across vast distances. Its interior heat drives convection, powering weather patterns that have persisted for centuries. Its magnetic field, generated by metallic hydrogen deep within, extends millions of kilometers, protecting moons and shaping the environment around the planet. Yet Jupiter is also a keeper of mysteries. Its core may be diluted, its metallic hydrogen exotic, and its deeper layers hidden from all direct observation. Each mission we send, from Galileo to Juno, peels back a layer, revealing new wonders, new questions, and new awe-inspiring truths about how mass shapes worlds. Even as we study and understand, the sheer enormity of Jupiter reminds us that much remains unknown, that the universe is deeper and more complex than we can fully grasp. Jupiter's moons, too, are part of this story. Europa's subsurface ocean whispers of potential life, Ganymede's magnetic field shields its hidden seas, and Io's volcanoes demonstrate the power of tidal forces driven by Jupiter's mass. Callisto preserves a record of cosmic history, while the tiny, irregular moons trace paths dictated by the giant's gravity. Each one is a testament to the planet's ability to influence, sustain, and sculpt the systems around it. Looking outward, Jupiter's role extends beyond the solar system. In a galaxy destined to collide with Andromeda, Jupiter remains the anchor of our planetary system, guiding planets and moons through the slow dance of stars and cosmic currents. Even as billions of years pass and the Sun evolves, Jupiter's mass ensures stability, continuity, and protection. Its presence is timeless, a silent sentinel across epochs. In comparison to other planets, both near and far, Jupiter stands as a standard of what it means to be a gas giant. Saturn, Neptune, Uranus, and distant exoplanets reveal variations in composition, storms, and magnetic fields, yet none combine mass, distance from their star, and stability quite like Jupiter. It is the archetype, the reference, and the ruler among giants, a reminder of the power inherent in sheer size and gravitational authority. Philosophically, Jupiter invites reflection on scale, time, and human perspective. Its storms endure centuries, its gravitational influence stretches across millions of kilometers, and its presence spans billions of years. We are tiny observers on a small planet orbiting a star in its gravitational shadow, yet through curiosity and imagination, we can explore, understand, and marvel at this cosmic giant. Jupiter teaches humility, patience, awe, and wonder. It reminds us that some forces endure, some structures persist, and some mysteries invite eternal contemplation. Even its subtle features, the faint rings, irregular moons, and distant captured bodies, contribute to the grand tapestry. Each particle, each orbit, each tiny interaction is governed by the immense mass of Jupiter, demonstrating the interconnectedness of all things in a system dominated by gravity and motion. Finally, as we drift in thought along with the solar system itself, we can imagine Jupiter in quiet majesty. The storms rage gently, the auroras shimmer softly, and the moons glide in faithful orbits. The planet spins, massive, enduring, and unyielding, a cosmic anchor in a universe of motion and change. Its presence reassures stability, inspires awe, and invites meditation. It is a world where mass is destiny, influence is inevitable, and grandeur is eternal. In contemplating Jupiter, we are invited to slow our minds, to reflect on the scale of the cosmos, and to find serenity in the knowledge that some forces endure beyond human time, guiding, shaping, and protecting. In this quiet meditation, the enormity of Jupiter becomes a comfort, a reminder of cosmic order, resilience, and beauty. The planet spins, the solar system moves, and we are witnesses to a universe both immense and wondrous, where a single planet's mass can tell a story of billions of years, countless moons, and enduring cosmic harmony. Jupiter is the giant, the guardian, the enigma, and the meditation itself, a planet whose mass shapes worlds, sustains systems, and inspires awe, now and for eons to come.